So let's talk about what containers are, first of all. So containers differ from virtual machines. So virtual machine is where you're actually emulating hardware. So you can have a computer that runs different virtual machines, and they all are independent of each other, and you can virtualize the whole instruction set. So that means on my Mac, I could run x86, or I could run a MIPS virtual machine, or ARM, or whatever. Very flexible, and they can be, any operating system basically, as long as I can emulate the hardware well enough. With containers, it's a bit more limited. What we're talking about today is containers for Linux. So they're very Linux specific feature, and they're not really, there's no container feature in Linux per se. There's really like a kind of collection of features that they put in the Linux kernel over a number of years to facilitate using containers. And the main ones that, as I understand it, are namespaces and control groups. So with a container, you're not really virtualizing a whole computer. You're sort of virtualizing the network, the mount, like the file system. Virtualizing process namespace, all that kind of stuff. And so every container has its own view of the file system, its own view of what processes are running. And they're also limited, you can set resource constraints, like this container only can have 300 megs of RAM, or only use this much CPU. And so those resource constraints are managed by control groups, or C groups, which they added in Linux, and namespaces. So there's namespaces now for, when you're running a Linux operating system, a Linux kernel, you can have process tree, process ID 1 in one container may be different from process ID 1 in a different container. And that's because their process trees are in different namespaces. Does that make sense at all? Please stop me if I'm throwing out any terms you don't understand or have any questions. Go ahead and interrupt me anytime.
I'm not really sure about the process trees.
Mm-hmm. Sure. So this is your process tree. So this is on my Mac. These are all the processes that are running. And it's kind of a tree because it's easier to see on Linux actually, but there's a process can spawn other processes, with fork or exec. So there's process ID 1, which will, it's like the first process that gets run by the operating system. Like when the kernel starts, it runs process ID 1. On Linux, this may be systemd. On Mac, it's probably, I don't know, launch control or something. And that spawns other processes. They spawn other processes. So each, on Linux, when you're in a given namespace, you'll see your own list of processes. So let me go ahead and just start up like Debian. Debian, you can say like Buster. And so now I'm running on my Mac container, but I'm not really running the container on the Mac itself because, again, containers are a Linux feature. So when you run Docker for Mac, what it actually does is it starts up a virtual Linux machine here. If you start Docker on Linux, it takes about a second. If you start it on Mac, it takes about a minute. And that's because it's booting a Linux virtual machine. Now, it used to be on Docker for Mac, you need something like VirtualBox or some VMware, some virtual machine software. But I think maybe 5 years ago or something like that, Mac and Windows started coming with built-in hypervisors. A hypervisor is a piece of software that lets you run, basically handle emulation, run multiple operating systems on one system. So on Mac, it's called HyperKit, I think. You can see here in Activity Monitor. It should be, because I have Docker running, there should be some HyperKit. Yeah, so you can see here, this is the actual process that's running a virtual machine on my Mac, which is running a Linux VM, which is then running Docker. And so when I can run a Docker image, a Docker container on my Mac, it's really running on Linux, and which is running on HyperKit. So it's a bit slower on Mac than on Linux because on Mac you're actually emulating a whole operating system to go with it. So with virtual machines, the upside is that you can have totally isolated different machines with different operating systems, different kernels, different architecture even. With containers, it's much more limited. You can only run things that run on Linux on the same architecture as the host. But the upside there is that you actually can share a kernel between the different containers that are running. So if I start this container and I start maybe another container, docker run. So these are two containers running on the same, I probably don't have PS installed. One sec. So these are two containers that are running on the same Linux virtual machine, but they don't see each other. They each have their own like mount, their own file system. They have their own process tree, their own namespaces and control groups for everything. Let's see, Pia, what is utils? How do you get PS? I forget. I forget the name of the package, but the point is I can run a process on this container, I can run a process over on this container, and they don't see each other. I can create a file like on root, and if I go over here and I look at root, I won't see the same file. They're both running in the same kernel, same Linux operating system code is running, but they see different things because they're in their own namespace. Does that make sense? So
yeah.
Okay.
So you have one image, but you can make multiple containers out of that image, which are like each separated. Is that correct?
Yeah. So you have one kernel. Let's call it the kernel. There's a Linux kernel running on the Linux machine, and you can have multiple containers running on that kernel, and they basically are isolated. Yeah. Now, what this means is that you can create lots of kernels, and they don't really use a lot of resources. You can create containers because they're sharing the same operating system kernel. So, I can spawn lots of containers. It doesn't really use much RAM, unless they're running programs that use a lot of RAM, of course. It doesn't really use much disk space, although each container has its own copy of the file system. So here, I don't have hello, but over here, I should have hello here. And then here I don't. Because these are both the same image, same Docker image, they actually aren't really using, it's just using the same Docker image, which is Debian, the official Debian image. They're both spawned from that image, but they both have, basically their file system is all in RAM. If I make any changes here and I exit, if I click end the Docker container, then all my changes go away. If you want things to persist, then you have to mount a volume into the image. And we'll talk about that a bit. So if I create hello here and I exit, if I run again, it will be gone because I just created a new container. And so any state I had in the previous container got nuked, it was destroyed. When I exit the shell, it stops the container. You can run containers in the background, but let's not worry about that right now. So containers are great because you can spawn lots of kind of isolated systems running on the same machine or not without a lot of resource overhead because you're sharing the kernel, whereas with virtual machines, they each would have their own kernel. So that would use considerably more resources and take a lot longer to start up each VM. So that's kind of why containers are useful. And they're good if you want to package up an application. So a good example is for HR tool, Dimitro made a container for headless Chrome. Because headless Chrome requires, certain files to exist, requires certain libraries set up. In the past, we would create a lot of custom services. So let's say you had an application that wants to send email. You would have to run postfix on your, somewhere in your cluster, mail server. Or if you wanted to serve files on the web, you would probably run Nginx somewhere. Now, we use Amazon. We don't really use Docker that much ourselves. We use Lambda. We use S3 for a web server. We use S3 for file storage. We use SES for sending email, all this kind of stuff. We don't really run many discrete services. We basically provide like an API server, and that's about it. And it's my opinion that for stuff like that, if you can build an application from the beginning and you have all the services that you need provided by your cloud provider, then use that. Don't bother with Docker. It's kind of not This kind of adds a lot of unnecessary complexity. For what we do. But there are lots of applications where Docker is useful or a good idea or makes a lot more sense, or if you have a large complex application with a lot of different services talking to each other, it definitely makes that a lot easier. If you have things that need to use a lot of maybe CPU power or run for a long time, Lambda is not so great for that. If you have existing applications you want to put in the cloud, it's usually not so simple to rewrite for Lambda, so Docker makes sense for a lot of use cases. So let's do something with Docker. So Docker, again, is not really it's for managing containers, and containers aren't really a thing. Docker is kind of a nice interface to using C groups and namespaces and all those features that make containers on Linux work. But Docker itself is really just kind of like a front end to these Linux features. Docker itself has a nice API and lets you write config files and build images and all this stuff, which is great. But when you're actually running things that's all in the Linux kernel, it's not really, Docker is not doing that much for you. Okay, so let's create a simple Docker file. I was playing around here. Give me 1 sec. All right. 1 second. I think I broke Emacs. I was trying to run Kubernetes in Emacs, which makes it kind of sad sometimes. Playing with the Emacs plugin. So in our Docker file, what we do is we describe a series of steps that we use to build our image. And then the images get saved in Docker. So you can go and you can type like Docker images to see a list of images here. So these are my Docker images that I have on my machine. And there's also kind of a central repository of Docker images that a lot of people use called Docker Hub. And you can go find stuff on here. So I was looking for Nginx, for example. They have Nginx built, various versions, various systems. And if you want to run Nginx or Debian or any of these other things that are on Docker Hub, it's really easy. You just, by default, it'll search for containers in this repository. A lot of people have private repositories. So Amazon has Amazon Container Registry service. I'm sure Google has their own. A lot of companies will build internal repositories of Docker images, which they use for building things, testing things, running applications, that sort of stuff. But let's say we want to create like a simple web server with Docker. So let's go ahead and do that. My E key is sticking horribly now. Demo, containers. So I made a really simple Docker file here. So the first line of a Docker file is usually from, and so this is a pre-made image that we want to build our image on top of. So Buster Slim is a slimmed down, smaller version of Debian Buster. And then we give it a series of commands to execute. And so, let's say we want to make some application available on that image. We could install Postgres client here. We can create a new user. First, we got to do apt update to get the latest version of all the packages. Then install, do our install, maybe add a user. It's usually best if you can to not run things as root, even in a container, because they have more privileges. If there's a, say exploit, maybe a process in your container needs root to run that exploit rather than an unprivileged user. So as on host machines, it's a good idea to run things in somebody not root. You can kind of set a current directory, run things as a user, do stuff, and then at the end, you usually have a command, which is like a default command or an entry point. And then you can just kind of use that Docker image as an application almost in some cases. So what I did here is I just thought, okay, let's try setting up an application that connects to Postgres. And so the default command here is to run psql to host PG as user Postgres. This won't be able to connect, but we can see an example of what it looks like. So I can do Docker build and then tag it. And so tags are like a name. So these are what like tags look like. A tag, it can be a repository. So here, this is in the internal Invite repository, and then like a name and then a version. So that's what a tag consists of usually. I created one here, which is a username / container name, tag latest, tag v2, and these are if you want to push stuff to Docker Hub. Docker Hub stuff is in this format. In custom repositories, it's same format, just you specify like a host name here. So I'm going to do build of something, we'll call it like demo, demo, and say build on dot. And so just use the current directory. By default, it'll look for a file called Docker file with a capital D. So this is my Docker file. Docker. Well. And so when I do build, these are all the steps. So each line of the Docker file is a separate step. And it built really fast because it's cached. So you can see here it says using cache, using cache. And one of the cool things about this is that each line here gets run in a new container. And a container is a checksum of everything that happened before, sort of like Git or like a blockchain or whatever. Each line here is cached. So if I change one line, so let's say maybe let's add run apt install -y Emacs. So -y means assume yes, don't ask for confirmation. So if I rebuild, it'll still have the previous apt update cached and the PostgreSQL client cached because I ran that already. So it's really raining. But the subsequent lines are not cached. So this apt-get install Emacs line is not cached, so it's going to run this, and this will take some time, as you can see. So this is really useful if you're building files, if you want to organize them so that maybe if there's some part you're working on that's later, you do all the stuff that's expensive that isn't going to change much earlier. And then, of course, this is cached as well. So Debian Buster Slim is made up of various layers. So each of these is a new layer, and you can actually see the layers as it builds, the different container IDs. And everything that inherits from Debian Buster Slim will use that. If I make another Docker file that uses the same base image, then I'm not going to download that image again. I'll just use the cached version. So out of this, I can make another image, and I can base another Docker file off that image, and so on and so forth. And you can kind of create a nice hierarchy or nice like kind of set of layers that are reusable if you want. So it's kind of optimized for that, which is efficient relatively. But it's something you have to keep in mind is each instruction here creates a new layer, a new kind of cache. So this is still running. And you can see these intermediate, containers here, each layer being created. And then at the end, it spits out this container, 634, blah, 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 and then it tags it demo latest. So remember, I ran here, tag demo, and by default, everything will have latest stuck on the end. So I can see this image that we created, Docker images. So here, 25 seconds ago, created demo, tag latest. See, it's 500 megabytes, pretty big. That's probably mostly Emacs. And then we can run it if we want. So we can do Docker run, and then if you're running something interactively, you have to do -ti or -t-i. And -t says allocate a TTY terminal, teletype interface, and then -i is interactive. So I can do that and then run demo latest or just latest, or just say demo. And then by default, if I run this, it'll run this command. Let's try it. Yeah, okay, so it doesn't know PG, that's fine. We'll get there. But it's running this command basically, trying to run PCP. can override that. Very useful thing is to run bash. If you want to go into your container and poke around and see, okay, what's inside here? I can see hi. That's the file that we touched here. And I can play around and I can, probably don't have sudo, but you can see I'm running as loser in home loser. And that's because I said work during home loser, user loser. Does that make sense so far? Any questions on that so far? All good? Okay. Now, with Docker, one of the useful things about these is that you can kind of take multiple images and put them together as different services. So a common thing, let's say we wanted to make a database-backed web application. We could, for example, run Postgres in Docker as well. So you can just do, if you want, you can just type Docker run Postgres, for example. And it'll go ahead and find it on Docker Hub and download it and run it. Now, if I want to run it, it says I need to specify a password. So in an environment variable, so we can pass in environment variables like this. And now I'm running Postgres. So that's pretty cool, right? Just anything that's been Dockerized is on Docker Hub. You can just run it on your machine like that. And it'll download it if it doesn't exist and just execute it in a virtual machine if you're on a Mac, or just in a container if you're on Linux. I mean, in a container either way, but you get what I mean. So that's pretty cool. Now it's going to tell me it's listening on port 5432. Now I already have Docker running on port 5432 here, but this is inside the container. So if I want to access things inside a container, I need to forward ports into it. So easy way to do that is I can say, okay, forward port, we'll say like 5433 to 5432. And what this will do is it'll listen on 5433 on the host, but inside the container, it'll forward to 5432. So in theory, I should be able to do psql host localhost -p5433 and talk to this guy. And we can see it's not going to let me in, but I am talking to the Postgres server here. So it's pretty useful for being able to grab pre-made services and compose them on your machine. Now, there's an automated way of doing this. It would be, if I wanted to, let's say, start up my application that depends on Postgres, I would have to start like either background this, which you can do. It's not hard. I can say -d, and it'll demonize and run in the background. I can start this up and then start up the other app once that's started up that talks to Postgres. But that's, nice. Would be nice to automate. There's a pretty common tool people use for automating this running multiple containers called Docker Compose. And you can go learn all about that here. This is the Docker Compose reference. So let's go ahead and compose two containers together. I'll show you what that looks like. So everyone more or less clear on the Docker file here? Yeah. Oh, it's really raining hard. So Docker file, default byte looks like this, capital D Docker file. And then Docker Compose is typically docker-compose.yaml. You can have other file names, but these are what it looks like, what it looks for by default. So this is what a Docker Compose file looks like. So let's go ahead and we can have it build. We can either specify an existing image, or we can just have it build the current directory. So we already have this Docker file here. So when I say build dot, it means, build from this Docker file in the same directory. Volumes is very useful. This is where we can mount a folder on the host machine, so my Mac, on the container, on the Linux container. And so it looks maybe something like this. So let's say I want to see logs from my application, or I want to see logs from Postgres or whatever. Or if I want to save data, so maybe I want to persist the Postgres data volume, you can specify a host point, mount point on the image here, and then where it is on the host. So it's like host path and then :container path. You can get a lot more fancy with volumes, but that's the general idea. So on What this does is it mounts the folder log volume 01, which is on here. It's just a directory, and it mounts it at /var/log. And so there's two services in this Docker Compose. There's my app. We can call it whatever we want, call it demo. And there's PG. And so here, instead of building it ourselves, we just say, okay, grab the Postgres :12 image. Now, if you want to know where this comes from, you can always go to Docker Hub and just search, for example, Postgres. And you can see here, these are the official Postgres images. You can see these are the tags, some reference, how to configure it, how to connect. For example, Docker Compose file, for example, environment variables, all that stuff. And you can see all the tags as well. So they have a lot of different versions on a lot of different kind of operating systems and architectures. So if we want to put these two together, we want to have our application, which tries to talk to Postgres. And a Postgres server, we can do it like this. So we'll set an environment variable, Postgres password foo, and we'll say we want this Postgres 12 image. And then we'll run our demo app, which just tries to connect with pSQL. And then we say here it depends on PG. So it won't create the demo container until PG container is created. So if we want to start this up, we can do Docker compose up is the easiest way. And we can do, yeah, just that. And so here we have Postgres running. We can see this is the output from PG1, and this is the output from the demo1 container. So we can see in different colors the output from each container. And we can see here that it actually did try to connect here. We just didn't send the password. That's fine. Let's see. I think if I remember, this might be wrong, but I think we can say inv pg pass equals foo. I'm not sure about this, to be honest. And if we want to rebuild, we can do this and specify --build. So this brings up both containers at the same time. Yeah.
And you don't have to forward the ports when using Docker Compose?
Good question. So you only have to forward the ports if you want to connect from the host machine. And so if I wanted to connect to Postgres from my Mac, I would have to do, I think, ports and then a list of port forwards. So 5033 to 5032, something like this. This isn't the greatest example, but you can see that it's trying to connect. It says no password supplied. That's fine. It just means that it did, in fact, connect to the database server. Now, the key to your question is the fact that we have PG here and PG here. And this is saying connect to hostname PG. So each container, when it's run by Docker Compose, gets a host name that corresponds to the name of the container. So on demo, if I try to connect to a hostname PG here, it'll connect to this container. And so inside the Docker Compose world, everyone has their own host name and can talk to each other. If you want to connect from outside that Docker Compose world, that container, all those containers, you have to forward ports into it. Any questions on that? Any of that so far?
I'm not really sure that I got the concept of volumes. So is a volume just on your host machine, a persistent storage for all the containers?
Not for all the containers, but basically you can mount. Okay, so I'm mounting here log volume 1 at /. Let's do a simpler example. So let's do Docker run, and I'm going to mount. I'm going to make a directory called, you know, like mount it, whatever. And we'll create a file and mount. We'll just like go hi mount like hello, whatever. So there's a directory on my Mac called mount. And I can go ahead and run, let's see, Docker run ti Debian buster, and then what we want to do is we want to mount, and mount usually requires a full path name. So if I want to do mount and then give it a path, so we'll say, you know, mounted. Let's see if that works. Actually, usually you need a full name here, like an absolute path, but maybe they fixed that. Okay, so now I'm in the container, and if I look, there should be a directory called mounted here. I can look at mounted, Okay, that's all right. 1 second. Might be that I need the full path here, the absolute path. Let me try this. Okay, there it is. So this file here is not really on the file system of the container. It's actually mounted through Docker. I wonder if I can see it here. Maybe, maybe not. I think it's probably this whole Docker magic overlay thing. I don't think we'll actually see it here. But on my container, I can do like echo like from container to mounted hello. And then on my Mac, I can go to the Mac and I can say cat mount hello, and I'll see from container there. So it's a way to communicate, a way to share files, a way to persist data. So if I kill my container now, everything that is on this file system goes away. So if I say touch like, you know, root, I can see there's a root here. And if I stop the container, if I exit, it'll stop it by default. If I run it again, that file will be gone. Root will no longer exist. But if I look at mounted, I still have my old data. So the most common use of volumes is to persist data across, you know, make it so you can start and stop the container anytime but not lose your data.
I get it.
Yeah. There's other uses for them. You know, if you want to share data from the host, if you want to maybe mount some secrets, like maybe you have a license file, for example, maybe you mount that from like whatever server is deploying your application. But most common use, yeah, is for persisting data or communicating. So if you maybe you want to run a development environment, maybe I run on here like my Python web application. Maybe I would mount the directory containing all my source code, and that way on my Mac, when I change something in the S code, the container sees it right away, rather than having to recreate the container each time you make a code change. You may ask, why don't we use containers for local development? We could. Right now, it would eliminate the need for us to set up Postgres and Python and poetry and all that stuff on your host machine. That's nice. I feel like our setup is not really too complicated to the point where I don't think that's a lot to set up like once. Basically just, you know, install postgres.app. It's really easy. Docker adds a lot of complexity that can get in your way when you're doing development. So for, you know, for example, if you want to connect to Postgres, now you have to forward the ports. It's not a big deal, but all these little things kind of get in your way and add up. If you want to, let's say, run a debugger, now you have to forward ports from your container to your host machine, so your IDE can connect to the debugger. It's also a lot slower if you're on a Mac, or Windows, because you're virtualizing everything. And also, it's not really any more accurate because we're not running Docker when we deploy our applications. They're not deployed with Docker, they're deployed on Lambda. So it's not really getting you any closer to our production environment. There are some tools that are useful for this sort of thing. I used to do this. There's something called Vagrant, which is great if you want to try creating dev environments that are based around Docker. Give it a try. I haven't used it in like probably 8 or 9 years, so I don't know what it's like now, but you know, feel free to play around. Maybe you'll find it useful, maybe not. I just like to, because our setup is so simple, it just makes a lot of things simpler for development if you're just using like your system Python, system Postgres. You know, there's nothing really getting in the way, but you know, there's nothing wrong with playing around with it if you want. Lambda is great. Again, if you're building an app from scratch and you can consume services from your cloud provider like we're doing, I think Lambda is simpler, but it's also a lot more constrained. You know, your application can't really get that big. You can't really have custom services running so easily. If you have something running for a long time, maybe running in containers makes more sense than running, like invoking Lambdas all the time, or you know, every 15 minutes when they time out, invoking them, that sucks. There's lots of ways to deploy Docker images to the cloud and run them. In Amazon, there's something called ECS, the Elastic Container Service. The idea there is you kind of run an agent on EC2 instances, and then you define Docker tasks that look something like this. In Amazon, they kind of have their own Dockerfile-like thing. And it'll schedule and run the containers on your EC2 machines however you want. Now, people don't really want to do that, so they came out with something called Fargate. And the idea there is you give a Docker image to Amazon, you say, run 5 of these, I don't really give a shit where, and Amazon will run it on their own server somewhere. So that's kind of a bit more serverless-esque, serverless-like, in that you say, here's my application, just run it, I don't care where it is. And then there's Kubernetes. And so maybe we can dive a bit into Kubernetes as well. Before we move on, any questions? Am I going too fast?
Oh, it's okay.
Clear. So Kubernetes, I think, I believe it comes from Google, and it's very powerful. It, I think, is used to run Google stuff. Yeah, so you can see they run billions of containers a week. It's very powerful, but in my opinion, it's a little too powerful for a lot of people. And I think if you're Google, Kubernetes is great, but if you're not Google, I think it's a little bit overcomplicated but you can do a lot with it. The upside is that it's super powerful, it's super modular. You can define all kinds of different complex setups with different load balancers and different services and all kinds of complex stuff. But it makes doing easy stuff pretty complicated. So Kubernetes is kind of a collection of services. Maybe there's some pictures here or something. Let's see. What is Kubernetes components? So it's something kind of like this, I guess. You have like a controller manager, API server, a scheduler, and then these kubelets and proxies and pods. Let's see. And so the idea here is you have these nodes, and the nodes basically are responsible for running images. And they're usually referred to as a pod. Pod is like a little self-contained service or whatever. And these pods get distributed on nodes. So you have a fleet of however many machines that are designed to run Docker images. And then Kubernetes is responsible. You define the desired state of everything in Kubernetes, and then it's responsible for scheduling your pods to run, your basically your Docker containers to run, figuring out where to run them. And if one of them dies, it'll just recreate a new one. So you can create this kind of nice, like, you define your application, everything about it in Kubernetes, usually with some config files, but it doesn't really matter what form it is. And then Kubernetes will make your stuff be run however you describe it. So it's really this, it all goes through this API server. And so that's why I say it doesn't really matter if it's in config files or not. Really, at the end of the day, you're just talking to a REST API. And you're saying, create a namespace, list services, update this pod, tell it to use this Docker image, stuff like that. And then the whole system, this whole control plane and the whole set of nodes can be anything. And so Google Cloud provides their own. Amazon, of course, has their own managed Kubernetes setup. You can run a kind of local, lightweight dev environment type thing. I don't do much Kubernetes. I'm still definitely a big noob at it. But the standard thing you do if you want to run it locally is something called Minikube. That's what I'm using. And Minikube will provide kind of the rest of the Kubernetes system around it. And so that means handling running pods, handling running the containers, load balancing, gives you a nice little like dashboard here. Looks like this. So let me show you how we set up that. So I have here Minikube running, and I just you just say Minikube start, And this will start up basically everything for you. It'll run Kubernetes. You can see it's using HyperKit. So similar to Docker, it's starting up a virtual machine. So we can see here it's running a Minikube VM. It's running Kubernetes on Docker. You can have some add-ons. Yeah. And then to manage Kubernetes, you use a tool usually called kubectl. And this will talk to whatever your Kubernetes cluster is. So again, locally, I'm running Minikube, but it could be talking, for example, to Amazon or to Google Cloud or whatever. So it's everything in Kubernetes is an object. Think of it like REST. You can get, like explain, get, delete, edit, anything, any type of object. And so there's some of the objects are things like deployment, service, pod, namespace, some other stuff. So namespaces here are different from the Linux kernel namespaces. Namespace is just where to put all your Kubernetes resources. It's not anything to do with what we were talking about before. So if I want to, let's say, deploy a service in Kubernetes, let's do that together. So first, let's make a little service. Let's make, I made a little web server here. It's very simple. So I just say from Nginx latest, copy directory called HTML to user share Nginx HTML. So this is an image from Nginx, web server. And if you go look at their documentation, they say just put your files in here and it'll serve it up. So let's just try that first. So I can just say docker run, let's forward a port, obviously. So let's say like port 8080 to port 80, Nginx latest. Let's just try that. So if I go to port 8080 on my Mac, it'll be forwarded to port 80 on the Nginx container that's now running. Whoops, not that. So I'll just go to localhost 8080, and there's Nginx. Cool. And so let's go ahead and build a Docker image with our HTML directory. So this is our HTML directory here. It's just got some stuff in it. So I would do docker build, and I'll tag it. Let's call it like demo Nginx. And let's put it on PBJ time. And I already was doing this earlier, so let's call it v3. And so this refers to Docker Hub. It's not going to build it on Docker Hub, but it's going to tag it with this and allow me to push it to Docker Hub if I want. Or I can just call it, just for now, I can just call it demo and say doc. Okay, so it'll build our container. It'll call it, tag it demo latest. And then we can go ahead and run the container locally. What's going on here? Why is it not building? What happened? Why is it not building? Okay, strange. Okay, so it built. Oh yeah, and I want to give it a file. I want to use the other Docker file. So this Docker file here is called dockerfile.webserver. By default, it uses Dockerfile, but I want to use a different one, so I'm going to use Dockerfile.webserver. Okay, so tag demo latest as my little Nginx service. So now I have this container, this little Nginx web server, tag demo latest. I can retag it. I can say docker tag demo latest revmish pbj time v4. And then if I want, I can actually push this up to Docker Hub. I can say docker push blah blah. And you can actually go on Docker Hub and find this now. Let's do that. Maybe it's private, actually. It might be private by default. Let's see. Oh, okay. Where are my images? Okay, there it is. It's public. Okay. I don't know why you can't find it, but whatever. So we can see there's our v4 tag pushed a few seconds ago. And when I pushed it, you can see it says layer already exists. That's because they already have Nginx in Docker Hub, so it doesn't actually need to push that layer. And the other layers I pushed before too, so it actually didn't need to push any data. it was a very quick operation because it's all cached on Docker Hub. It just says, hey, do you have these layer versions? Yes, okay, I don't need to send that anymore. Okay, so we got our container, our Docker image rather, not our container. By the way, point of terminology, containers are what's running. So if you do Docker PS, it'll show you the running containers. Right now, nothing's running. If you do Docker images, it'll show you the images. And so Docker containers run images, but they're not the same thing. It's important to keep in mind. Okay, so we have our service. Let's deploy to Kubernetes. So I can run kube control. First, let's make a namespace. A namespace is just where to put, related stuff, just like a folder, sort of. So we can say, first, let's say get namespace. And it should show us all the namespaces in our cluster. So these are what I have. Most of these are from, what do you call it? Invite. Can also see it. So there's the command line client. Of course, there's lots of different ways to talk to the Kubernetes API. There's a web-based one, so I can type minikube dashboard like this, and it'll open this nice little web interface. You can see your namespaces here. This is the same list as before. And you can see other stuff on here. I don't really like this interface. It's way too fancy. Personally, I was using K9S, which is this guy. And we can see the same data here. These are all my, so namespace, and then these are pods. So these are like kind of containers that are running. You can go look at them. We'll do that in a sec. And of course, you can do it in Emacs as well, if you're into that sort of thing. Here's my default namespace. I can say, let's go ahead and change namespace. Well, we'll get there. Let's not do that just yet. First we need to create a namespace and deploy our service. So let's do that. So we can do kube control, or as you know me, I'm a lazy typist, so I just type K. K, I think we do create namespace, and let's call it demo. Great. Now we have demo created. We can do list, kubectl get namespace. See our demo namespace appears here now. And then there's a few ways we can set up our service, but I think we can talk directly to the API, but usually the way you do it is you create a config file, a YAML file. So I made a sample service YAML file here, and this is what a Kubernetes, Kubernetes doesn't really read the config files directly. You can run a command which will take the config file and talk to the API and basically configure everything in Kubernetes according to what you have here. So this defines, so I say, okay, this is inside namespace demo. You can give everything a name. Every object definition has an API version and a kind. And so this version is, matches, it has some schema, which we're matching in this configuration, and then the kind is the type of object we're creating or updating or modifying or deleting or whatever. So I want to create a deployment, and that says, I want to take some Docker image and run it. And so there's the metadata, and then there's the spec, the specification. And the idea with Kubernetes is you set specifications, you define the state that you want it to be in, and then Kubernetes is responsible for getting everything into the state that is defined. But there may be some lag, or there may be some failures between the state you want and the state is actually in. So it's very clear to specify that you have your spec, which is the desired state, but it may not be the same as the current state. So the state that we define this way. So we're going to say we want to run a container, give it a name. Name doesn't matter. We give it an image. So here we'll go ahead and use PBJ time v4, latest version. It can expose some ports. So we're going to say our container is running on port 80, which Nginx is. And then we can give it some labels as well. And so this label is used if we want, can be anything. Labels is basically a series of key value pairs that you can use to match to say, like, I want to select all web servers, or I want to select all Nginx services, or I want to select all, whatever. Just arbitrary ways to keep track of stuff. So this basically says I want to deploy this image. It's just kind of a long-winded way of describing that. Set like number of replicas, so how many you want to be running, like how many, tell Nginx, like make sure there's always 2 of this service running. Right? And then there's a separate object called service. So here, this is a separate object of type service, and we can define, you can create a node port. This is like how you reach the service. So it can be node port, it can be load balancer, it can be some other things. But you can say, okay, let's expose port whatever. This is the port that would be exposed by Kubernetes cluster, goes to target port 80. So if you connect to this service on port 8899, it'll go to port 80 on the container. And then we say we want to select app Nginx, and this matches, I believe, this label here. Or it might match this thing, I'm not sure which of these it uses, but basically, this is how we say, okay, whenever anything comes in port 8899, send it to port 80 on the Nginx, things tagged to Nginx. Any questions on this? No. Okay.
Yeah. If we have 2 Nginx instances and we hit 8899, how does Kubernetes decide which one we contact?
That is totally up to Kubernetes. So so here's this different service type. So you can, if you want, you can specify a load balancer. You can also use other things, like probably on Amazon, you can say like API gateway, for example. And then it's up to that service type, to decide where it goes. So if you look, for example, here on load balancer, they have, a lot of different customizations depending on what's actually responsible for doing this. What's doing the proxying, what's providing the service. So that totally depends on these. And then somewhere in here you can set like, I don't remember where exactly documentation is, but you can say like, okay, do round robin, do affinity, so that like, pick a random Nginx, or always have the same client go to the same server, or I don't know, yeah, this kind of stuff. So there's different ways to specify that behavior that you want. For us right now, we don't really care which one it picks. Now, the thing that's going to be mapping my service to my container is Minikube, because I'm running Minikube locally. If I was running this on AWS, it would be some Amazon thing. And then here's some other setups they have. You can use IP tables, which is the firewall in Linux, or you can have kube proxy, run it in user space, or you can do a lot of different ways to route stuff internally. Again, very complex, can do anything, but also is pain in the ass. Yeah, that's kind of the more complex, the more stuff you can do, the more complicated it gets, the more hard it is to configure and do simple stuff. Kubernetes is definitely at the extreme end of that spectrum. Okay, so how do we actually run this in Minikube? Tell this to go be deployed. Easy way to do that is we can run kube control apply and give it a path to a config file. So I'm going to do that here. And we can see that it created my deployment and my service. And if I run it again, you can see it didn't do anything. It sees that nothing has changed, so it's not going to do anything. Now, if we go over to K9S, or to here, or to the web interface, or whatever, it doesn't matter, we'll see the same stuff. So let's change, let's change namespace to demo. And we can see our deployments here. There it is. Similar demo deployment, we can see we have 2 out of 2 replicas. We can see, update strategy. We can see our pods. And then these are the containers. We can actually go, like, for example, look at the logs. Cool. We can follow the logs if we want. Same, again, it doesn't matter how you're talking to the API. We can do the same here. We can say, okay, here's our pod, show me the logs, whatever. We can see like port forwards. We can see all this stuff. Basically, go look at the cluster. We can see it in the dashboard. It'll look something like this. So if we go to demo, cool, here's our deployment, here's our pods, here's our service. You get the idea. It's all the same, different views on the same cluster. Now, if we want to talk to this, we can't really talk to it directly because this is the IP inside the Kubernetes cluster. So if we want to talk to it, we have to go through some sort of service proxy. Because I'm running Minikube, I have to go through Minikube on my machine to actually talk to one of these Nginx pods. So for Minikube, I can go over here. Let's see, let me quit this. Minikube, I think it's service list. Yeah, so these are the services running. I can see here, here's our demo Nginx service, and this corresponds to, let's see. So here I'm looking at, I think, deployments. I can say, show me services. This is demo Nginx service. And this corresponds to this guy here. So this is listening on port 8899. That doesn't really matter, though, from the perspective of my host of macOS, because macOS doesn't know anything going on inside the cluster. So we can see here, Minikube is exposing this port, which goes to 8899 on the service, which then goes to 80 on the pods. So there's a few layers of indirection going on here. And I can go to this here on my machine, and now I'm talking to my Kubernetes cluster. Cool. We got peanut butter jelly time. That's what's running in the Nginx web server. So again, this is just taking a Docker file and deploying it and talking to it somehow. But this is the sort of extreme enterprise, super complex way to do it through Kubernetes. Yeah, I think that maybe we can look at the logs, just see what that looks like. Maybe in K9s. So one of these pods should have some access logs, I think. Let's take a look. Yeah, there it is. So there's our web server access logs. Pretty cool. All right, I think that's pretty much what I want to demo. Any questions on that? Anything you want to look at more?
So in our LinkedIn scraper, where we want to like remember the credentials that the user passed in and then reuse them, so will we have just like a file with credentials which we will mount as a volume and take credentials from there?
Sure. Yeah, that is definitely one way to do it. That would work. If this was going to be like a real service, then you usually want to get secrets involved. So there are ways to pass in secrets. Different ways of doing it. To be honest, I'm not very familiar with most of them. I think the simplest way to do what you're talking about, because we're just going to be running it on our own machines, yeah, just mount a volume, and a volume can just be a file. It doesn't even have to be a whole directory with the credentials in it. And maybe use Docker Compose to define everything. And then, yeah, when the container runs, it'll have that file. That file would live on the host, not on the container. But you would mount it in the container, and then the container would look at those credentials to run. We could use, if we were deploying this somewhere, we would probably need to set up some secrets thing to pass those in. But we're not doing that, so yeah, I think what you said is fine.
The container can have any number of volumes mounted?
Yeah, a lot. You can mount a lot. Sure. I can show you a real one, for example. don't think there's anything secret in here. This is the Docker Compose for some of the data engineering for like local development environment for Invite. So there's like, this is all just generic stuff. There's nothing Invite specific. But you can see like, set up environment, lots of ports. You can have lots of volumes. You can, do a lot of stuff. Yeah, you can have more than one port for sure.
Because like there was an issue with invalid session ID, which was like bugging me for some time. And the reason was that in the container, which was running headless Chrome, like the space in dev//shm folder simply ran out, and Chrome crashed because of that. So I had to mount it as a volume, and then this issue disappeared.
Is dev/shm a directory or a file? I guess it's not on Mac, but is that a directory or a file?
Yeah, it's a directory.
SHM is shared memory, by the way. It's like if you want to have a chunk of RAM that's mapped into multiple processes, that's what SHM is.
Yeah, and I believe Chrome loves eating some RAM.
Yeah, I bet. Any questions? Any other questions? Anything else? Anyone? All good? All make sense?
Yeah, thanks for this presentation. It was really cool.
Sure, yeah, anytime. Again, we don't use Docker much. We use it for a couple of things.